Hello students, this is Mr. Ezra. Today we are going to continue working in Unit 6, which is a unit on statistics by talking about samples, experiments, and observational studies. The big question here is, where does data come from? There are lots of different places that we collect data. One way that we collect data is using a survey. A survey chooses a subset of the population or a sample of the population and asks them questions or interviews them to collect data. For example, if we ask 50 shoppers at the mall what their favorite store is, we have taken a sample, a smaller group out of a larger population, and asked them the question. Some other different sampling methods that we see. One is a self-selected sample. This is when members of a population can volunteer to be in the sample. A lot of times internet surveys where you click on the link and then you take the survey are self-selected. And I should note that self-selected surveys very rarely give you good data. Usually there's going to be what we call bias in the data that we get from a self-selected survey, because the people that self-select to be part of the survey usually have stronger opinions about something than the general public. Another type of sampling method that is used is a systematic sampling method. We use systematic sampling methods usually when we have things that are in a line, for example, an assembly line, or people who are queued up or lined up at an amusement park getting on or off of a ride. The rule is going to allow us to select members of the population by basically using a pattern to select every 10th person that gets off of the new ride at the amusement park, or every 25th bolt that comes through the assembly line, and then they'll inspect those things based, or those people or things based on that pattern. Another type of sampling method is a convenience sampling method. Convenience samples are very widely used, but they very rarely give you good data. You basically use a very convenient, easy way to reach members of the population that are selected. So maybe you want to talk to people about school lunches, so you just talk to the first 10 people you see in the Bulldog Cafe. That's not going to give you good data necessarily. It's really easy to collect it, but you're likely to have what we describe as bias. A random survey is usually desirable. I mean, this is where every member of the population has an equal chance of being selected, that there's some kind of randomizing strategy in how you reach them, and this is usually how we get a good sample. Stratified samples, we divide the population into groups first, and then we look at each of those groups separately and do a random sample in each group. So for example, if I stratified students at our school based on their grade level, 6th, 7th, 8th, 9th, 10th, 11th, and 12th, and then I did a random sample of maybe 20 students in each grade level, that would be a stratified sample. Cluster samples are also samples based on groups, but it's a little bit different. The population is divided into groups, and then you randomly choose whole groups to be surveyed. So for example, if I look at our school and we basically get like a map of the school and every classroom is labeled separately, and I randomly choose during second period to choose 7 classrooms, and I interview every student in those randomly chosen 7 classrooms, that would be a cluster sample. When the group is selected, every member of the group is surveyed. Some of these, as we said, are not very good sampling strategies. Self-selected sampling strategies, not good. Convenience sampling methods, not good. But the systematic, the random, the stratified, and the clustered are all usually productive if they're used in the right setting. For example, a teacher wants to find out how many hours students studied for a history quiz. What type of sample is described? Before leaving the room, the teacher asks students to write the number of hours they studied for the quiz on the whiteboard if they want to participate. So looking at that list of strategies from the last few minutes, which do you think it is? If you say self-selected sample, then you are correct. By allowing the students to choose whether they want to participate or not, we're allowing them to self-select their participation. Usually when this happens, there is something that is called bias. Because the students who say, I would like to be part of this sample, are probably more likely to have studied for the quiz and to say that they've studied. If you didn't study, you're not likely to be one of the ones who choose to participate. Part B. The teacher instead selects students randomly from an alphabetical list and asks the selected students how many hours they studied for the quiz. The key here is that she did it randomly. That would make it a random sample. We sometimes call this a simple random sample. Simple random samples are great samples. They very rarely have bias. And bias is the question, or is the answer to the question, is the data trustworthy? If there's bias, the data is not trustworthy. We're not likely to have what we call a representative sample of the population. But if we have good trustworthy data, then it's likely to be a good representative sample from the population. Bias is, as we said, you can think of it as there's this truth about the population. And when we get biased samples, we are not representing what's true for the population. We're either overrepresenting it, underrepresenting it. If we're trying to shoot a target, we are not hitting the center of the target. We're hitting off to the side. Unbiased samples happen when the sample that you get is a good representation of the population. Usually this requires randomness in the selection process. When you're shooting your arrow at the target, you're going to hit it. You're going to hit the middle of the target when you have an unbiased sample. You can sometimes decide whether or not it's biased or not by thinking about who would be answering. Would they be more likely to feel stronger than those who are not answering it? When and where are they answering the question? That could have an impact on whether or not there's bias as well. If I stand outside of the Apple store at the mall in Atlanta, and I ask people whether or not they prefer Apple's or PC products. Well, where I'm standing is probably going to influence the results. If they're shopping at the Apple store, they may be more likely to choose the Apple product. So there's definitely going to be bias there. We'll be overrepresenting those people. Back to our two examples. We already have mentioned this before, but let's formally say that the self-selected sample from A was biased. Because the people who choose to tell the teacher whether and how long they studied for the quiz are probably more likely to have studied, and we're probably going to overrepresent how long students studied. But the random sample cuts that bias out. Anyone has the same chance of being selected, whether or not they studied a lot or not. That is going to be unbiased, and random samples are almost always unbiased. Let's move on to the difference between experiments and observational studies. So, experimental design has some specific vocabulary that you should know. First, when we talk about individuals in the study, in the experiment or in the observational study, these could be people or animals or objects that are described by the data. Usually when they're people, we call them subjects. So if it is a person, sometimes we'll say the word subject instead of individuals, but individuals could be anything that we are studying. The variables are the characteristics that we're using to describe the individuals. Treatment groups are experimental groups that receive some sort of treatment. There's something that they are asked to do or that they are given that is out of the ordinary for them. And a control group is an experiment group that does not receive the treatment. We use this so that we have some point of comparison for the treatment group, so that we know whether the treatment is performing better than no treatment at all. There are different ways to have a control group. In drug trials, often the control group is called a placebo group. They get a pill, just like the treatment group, but their pill is fake, doesn't do anything. It's a sugar pill. Just basically looks like the treatment but has no effect on the body. And that way we can get people who don't know which one they've gotten, and we can test whether or not the pill does better than the placebo or not getting the treatment. You can also have a control group that is the current way of doing things. Like if there's a current product on the market and you want to test a new product, you can have the treatment group be the new product and the control group be the old product. And also control groups can be no treatment at all. You're testing some type of additive to the soil for plants. The plants that are in the treatment group get the additive. The control group plants get no additive. They don't get a treatment. They're just there to have as a comparison. There is a little bit of math here, or a little bit of computation, I should say, how to convert from a sample proportion or sample number of responses to the population. So um, based on a sample, we use the results of a statistic to try to estimate the parameters of the population. And in other words, if we have a good, unbiased, representative sample, we can use that good, unbiased, representative sample to understand the population better. We can do this in some cases by setting up a simple proportion, which looks like this. The statistic, which is the proportion, I guess, out of our sample size, is equal to our estimated parameter out of our population size. For example, a car factory just manufactured a load of 6,000 cars, but they don't want to test all 6,000 of those cars. That would be expensive and time consuming. So the quality control team randomly chooses 60 cars and tests the air conditioners of those 60 cars. They discover that 2 of the air conditioners do not work. So if this is a good representative sample, then how many of the manufactured cars would we expect to have broken air conditioners? We're going to set up a real simple proportion here. We're going to basically say that 2 out of the 60 in the sample did not work. We're going to set that equal to some unknown number out of the population of 6,000. So you'll see here you've got your sample result out of the sample size is equal to the unknown population result out of the population size. Remember, to solve a proportion, you cross multiply. We use cross products, so we'd say 60 times x is equal to 2 times 6,000, or 60x equals 12,000, and then all you have to do is divide both sides by 60 to get 200 air conditioners would be expected to be broken. Now, our sample is not going to be a perfect representation of the population. We can't expect exactly 200 air conditioners to be broken, but based on our random sample, our good sample, we expect about 200 of them to be broken. That's our best estimate. Another example, in a survey of 40 employees at a company, 18 said that they were unhappy with their pay. The company has 180 employees. How many of the employees would you expect to be unhappy with their pay? Well, remember, we set up our proportion by saying the number in the sample who said they were unhappy divided by the sample size is equal to be 18 out of 40 is equal to the number of in the population who are unhappy out of the population size, which is x out of 180. Again, cross products gives us 40x equals 18 times 180, which is 3240. We divide both sides by 40 to get 81 employees. So what we would expect, the number of employees that we would expect to say that they are unhappy. Is it exactly 81? Probably not. There's variability when you sample. Sample results are going to be different if we take different samples, but that's our best estimate based on our good sample. Experiments, you can tell an experiment is an experiment because there is a treatment that is imposed on the individuals in the experiment in order to collect data. A researcher adds acetone to gasoline to measure its effect of the fuel efficiency. The addition of the acetone is a treatment. If you see that something has been changed or added about the setting, or the individual's been asked to do something that they would not normally do, it's out of the ordinary for them, that is a treatment, and that lets you know that you have an experiment. In a controlled experiment, 2 groups are studied under conditions that are identical except for the one variable that you are studying. Randomized controlled experiments are going to have random allocation, which means that you have a pool of people in the experiment or a pool of individuals in the experiment, and you're going to randomly allocate half of them to the treatment group to get the treatment, and half of them are going to be randomly allocated to the control group to get the non-treatment in order to have a comparison. In a randomized comparative experiment, the individuals are assigned to a group at random. We can have at least two groups, control group and treatment group. Now, you can have more than two groups. It's possible to have more than one treatment. You can have different levels of treatment. And if you're testing some additive to the soil for a plant, you might have different amounts of the additive that you add to the soil so that you can not only measure the addition of the additive, but also the concentration of the additive. Observational studies are a bit different. There is no treatment here. We are going to observe individuals in their environment. Whatever happens naturally, that's what we are observing. And we'll still measure variables, but we're not going to control. We're not going to change the environment in any way. We're not going to ask people or individuals to do anything out of the ordinary. We're just going to observe what happens naturally. Now, both experiments and observational studies have the observational component. We're going to observe in both of them, but experiments have treatments and observational studies do not. For example, a researcher wants to find out if poor nutrition affects eyesight. But it would not be ethical to make someone have a diet that consists of poor nutrition. So they're not going to set up an experiment where they make someone have a poor diet. Instead, they're just going to find some subjects who are already subject to poor nutrition and then look at their eyesight. They're going to set up an observational study. So let's explain whether this situation is an experiment or an observational study. A researcher wants to know if a soil additive makes a fern grow more quickly. Oh gosh, I've kind of been giving this one away and I didn't even know it. I forgot that this was in here. So he grows one specimen in a treated soil and one in an untreated soil. Did you pick up immediately that the soil additive was a treatment? And since it is a treatment, this situation is an experiment. Whenever you notice a treatment, you want to say experiment. Let's do the same thing with this example. To find out whether car accidents are more likely on rainy days, a researcher records the weather conditions during 50 randomly selected accidents from the past year. So think about it this way too. Is there a treatment here? I hope that your brain says no. But you also should be thinking that if we were to try to set up an experiment here, it would be highly unethical. We're not going to force people to drive on rainy days in hopes that they may have a car accident or be more likely to have one. That would be really unethical because people could be severely hurt or injured, or even worse. So the researchers here are trying to gather data without controlling the individuals or applying any kind of treatment. They're looking at what has happened naturally over the past year. This situation is an example of an observational study. Example 5. We want to here describe the treatment group, and the control group. So we know that we have an experiment. 100 arthritis sufferers report the severity of their symptoms daily for a month. 50 of the subjects were given Epsom salt to bathe in at least every other day. At the end of the month, 30% of the subjects who used Epsom salt reported a decrease in severity of their symptoms compared to 5% in the other group. And we're going to consider that the other group did not get Epsom salt or any other treatment, that they were identical except for the Epsom salt. So the treatment here is the addition of the Epsom salt, bathing in the Epsom salt. The treatment group would be the group of people who bathed in the Epsom salt, the 50 subjects who bathed in the Epsom salt. While the control group would consist of the 50 subjects who did not bathe in the Epsom salt. Here, let's decide whether we would best be able to do an experiment or an observational study here. Does using tanning beds at least twice a month affect the likelihood of developing skin diseases? Well, if we think that it might help to develop skin diseases, would it be ethical for us to ask people to use tanning beds at least twice a month to see whether or not they get skin disease? That would be a treatment, right? Asking them to do that. And that is not ethical. We wouldn't want to do something that could cause someone harm. So instead, we're going to perform an observational study. We're going to look at people who are already using a tanning bed at least twice a month and see if they seem to have a higher likelihood of developing skin disease. Since the treatment may affect the health, it's not ethical to assign individuals to treatment groups. Let's classify each of these as either a survey, experiment, or observational study, looking at each separately. Method A. Choose 50 people who have at least one serving of soy a day, and 50 who don't, and check their cholesterol levels. What do you think? Which of the three? If you chose observational study, you are correct. We have found people that are already having at least one serving of soy and who are already not having and just checking their cholesterol levels. So we're not asking them to do anything out of the ordinary. There's no treatment here. We're just observing different groups. Method B, randomly choose 100 people. Out of those 100 people, ask how many servings of soy that they have had a week and ask if their cholesterol levels are higher. Well, sounds here like we are uh, using a good randomization strategy to collect a sample. And then in that sample, we're asking them some questions. So if you chose survey here, you were correct. And finally, method C. I guess I could have put more than one of the same, but my guess is this is probably an experiment. But let's read it and see. Randomly choose 50 people to eat at least one serving of soy a day and 50 people to not eat soy every day and monitor their cholesterol level. So here we are imposing a treatment. We didn't find people who are already eating soy. We are asking them to eat soy. That makes it an experiment because of the treatment. Well, that is it for today. I know that this might be a strange lesson for you since there wasn't technically a lot of calculations, but there was a little bit of math in here. But really, this is very vocabulary heavy. So as you're getting your notes together and doing your practice, um, remember that to prepare for the test, you're going to have to make sure that you are good with this vocabulary, that you understand the terms and that you understand how to apply them correctly.